Right, this worksheet should be on your desk as you came in. This is just a review and overview. Real quick, tell me how to rewrite number 3. This is a worksheet that was on your desk when you came in. It says sections 1 to 3 on the top. Can anybody tell me? Yes, I've lost my cursor. Hello. All right. It's gonna be like this today. You would write log base x of 44 equals y. Okay? So can somebody rewrite number 5 in exponent form? No log. I'm doing 5. M to the n equals 180. All right? Are we good there? All right. Further down, we have rewrite into a single log. This you also have to be able to do without a calculator, which shouldn't be a problem. But what does divided by 2 mean? Yeah, it does mean 1/2. And what does a 1/2 do when it's multiplied on the log? It is an exponent, so this becomes okay. Now, what does a 1/2 power mean? Square root. All right, and what does plus mean between all these? We can condense it into one multiplication. So we're going to have log base 4 of c times the square root of a times the square root of b. Can we multiply 2 square roots together?
Yes.
Yes, you can multiply anything together. You just can't add things that aren't. All right, so there's number 8. Okay, everybody good? Expanding, this one is a little tricky. Do you want to try 10? There's 2 different ways you could write that one. What do you want to do first?
Put the 4 out.
Put the 4 out front. Anybody else? What do you want to do next? This quiz is going to go really well on Thursday. Yes. We can switch this into 2 logs. We have an a squared minus log b. Okay, because of the division, yes? Did I lose anybody? Maybe Caleb. We could move this 2 in front of here. Did I lose something? No, you gotta have parentheses there, yeah. So we could write it as this. Yes, you could, this I would accept as an answer, or you can distribute the 4, so then it would say 8 log base 8 of A minus 4 log base 8 of B. I would like to point out to you that if you had simplified this and made it an a to the 8th over a b to the 4th, would that have made sense right there? Okay? Doesn't matter, but, and I will accept this with it without distributing it, but it's a good question. And it ties those laws of exponents and laws of logarithms together. I'm not sure I said that right still. All right. These are without a calculator, please try them without a calculator. That's what you're gonna have to do on Thursday's quiz, okay? Check yourself on the calculator when you're done, it's fine. On the back, in the back of this worksheet are just some review concepts. Do you wanna go over some of this or not? Maybe just the top right here, cause I know Caleb at least was gone yesterday. Can someone explain the product rule here? How can we rewrite this product of 5 times x? Yes. When you have the log of a product of 5 times x, you can rewrite it as the log of 5 plus the log of 3. It goes back to this when it was a multiplication problem, Caleb, you added the exponents. When it's a multiplication log, you add the logs. All right, the quotient rule, guys. Quotient means divide, so what are we gonna rewrite that as?
Log of 5 over log of 6.
Nope.
Oh.
Can't take 2 separate logs and that are subtracted and rewrite them as 2 separate logs divided. You gotta combine them into one. It's y over 17. Minus divide, we're good? Okay, so an example of that would have been if you had y to the 12th over y to the 3rd, you should have subtracted and gotten y to the 9th. That's with exponents. This is with logs. When you have 2 separate logs subtracted, you can combine them into one divided. Division meant subtract exponents. Division meant subtract logs. All right, product or power rule, where does the power rule, where does that go? Yep, just multiplies out in front. That would go with an exponent problem like this. Okay, you get a 2 to the 3rd and x to the 15th when you do that problem. You multiply those. So you move this out as a multiplication. Becomes -5 times the natural log of 2. Change of base. I really like this question. They wrote them both as base 5. Well, what purpose is that? Can you do a base 5 on your calculator, on a normal calculator, scientific calculator? No. But before it was this, okay, do you remember how it goes? Which one goes on the top when you rewrite a log question? If I had log base 2 of 12, how would you type that in if you had a scientific calculator?
Log of 12 divided by log of 2.
Yes, this would be log of 12 divided by log of 2. Okay? So this was log of 3x, and the base down here was 4. Okay? Then, but why they rewrote it as log base 5, I have no idea. That's just a weird question. Thank you. For further explanation of why that works, guys, I did all the rest of these, but my best explanation for that one, if I told you to evaluate the log base 2 of 12 like I did over there, you could rewrite it as 2 to what power equals 12. Then you would take the log of both sides. You would move this out in front. And then you would divide. So that's where we got this eventually. Okay? Just trying to show you one more time how they all work. You did not have algebra last year, right? So this is 2 years or more since you've seen logarithms.
Yeah.
Yes. Okay. This is just find 2 numbers that work. I'll let you fiddle around with that one. These are true, false. You can do these on your calculator, and I'm fine with that, but there is a typo on one. We tried to do this question last period, and we spent 15 minutes trying to figure out why it didn't work. There's a typo on here. This needs to have a negative. Okay, so put this little negative on C. Okay. Otherwise, it will not match one of these graphs. That's just, you can just do this as a calculator typing question. All right, what else? What about questions from worksheets 13, 15, 17, or 18?
Amber, on this worksheet, I totally forgot how to do this without calculator. I
Okay,
kind of just
yep.
the concept, but,
Let me back up.
um,
I really want this to work. Is it working yet? So I don't have to stand in your way, but that's not working. Now it started to work and then I turned it off again. Well, let's leave it on and see what happens.
yeah.
Just real quick, A is false, right? I don't know where that random A mark came from.
Actually, if you move the 4, it would go on all of this. So 3x to the 4th is 3 to the 4th, x to the 4th, which is that, so I think that is true. Okay? This is the one I got wrong. D? What do you think? What do you think about D?
I said false.
It is false because of the parentheses. The whole thing is to the 12th. If it had said just log of y to the 12th, then you would move it out front. But this is the whole thing to the 12th. I couldn't figure out why it was false when I looked at the answer key, but that's why. I just didn't, I totally ignored the parentheses, like they weren't even there. Which question? Number 17 this time? Amber?
Yeah, I like any of them, but,
Any of the whole thing?
well, yeah, 'cause I don't remember, like, how are you supposed to, like, set it up?
You have to, well, you just told me how to set it up when you did this question for me a minute ago. M to the n equals 180. Okay? So if we're doing number 11, this means 64 to the what equals 1/2.
Yeah, I don't know, like. how you-
Yeah, that's,
That's-
that's a hard one. What are those both powers of, guys?
2.
This is number 11 on the front side of the worksheet. They're both powers of 2. We need to figure out what 64 is. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, so we're up to 6. So this is 2 to the 6th. And we don't know what this is. But we know this is 2 to the what? What would put that 2 in the denominator? So now we can say 6x equals -1, and this is -1/6. That was ugly.
How'd you get a, wait,
This is 2 to the 6th to some unknown power.
So then what about what would you
That should be easy.
3 to the power is 43?
Yeah, except it's a big number, huh? Okay, 3 times 3 is 9, times another 3 is 27, times another 3 is 81, times another 3 is 243. 1, 2, 3, 4, 5, 3 to the 5th. Someone use their calculator. Should be right. So the answer is 5.
so does that mean for 13 it'll be 1/3?
This is 3 squared times some power, which is just a 2x. It's 1/2, right?
Oh, okay.
9 to what power is 3? The square root of 9 is 3, so that's the 1/2 power. Does that help? I didn't realize some of these were so tricky.
They get fun.
What?
They get fun.
I'm sorry, next question first.
Yes, what else would you like to know?
Number 3 on 15A.
Right, worksheet 15A. That's this one?
Yes.
Number 3 just wants you, oh, number 3, the put $1 in question.
Okay.
So if I put $1 in, I leave it for a year and then I take it out, which one makes more money? So this was on the, page before this, worksheet 14, I think. But it's 1 times 1 plus 0.0875 divided by 4, because it's quarterly, and then to the power of 4 times 1, and then take out your dollar and see what you get.
Is that 0.8 divided by?
Yes, 0.0875 divided by 4. This one would be putting $1, 1 plus 0.087 divided by 12 to the power of 12 times 1 year, and then you take out your dollar. They're gonna be very close. You need to go out several decimal places, but one should give you a slightly better rate of return. Okay?
I'm just trying to do the
Okay, on that other worksheet? Brennan?
Worksheet 17, I got 2 questions. Can we do the half-life questions? I don't know how to.
Yeah, I will talk about the half-life. There's actually a half-life on this one we can do as well.
If they're both on the bottom, like if they're both a fraction.
Then you would just like square it or cube it or whatever to get it to that. That answer your question?
Yeah.
Okay, good. I'm gonna stick to this worksheet for a second. Can I talk about the half-life one that's on here? Except I'd like to get rid of the ink on that page.
What page number is
Or I could just erase. This is worksheet 15. Okay, no, that's not the one I wanted to do. Did I already set this one up for you guys?
Yeah.
This is not a half-life.
Number 6.
I want to go to the next one, now that I erased it all. Okay, half-life, sorry. Half-life of a certain radioactive substance is 14 days, and there are 4,000 grams initially. So, if we started out with 4,000 grams, I really want that in the Y column. It's not gonna let me move it. So at day 0, there's 4,000 grams. Does that seem okay? How long until it's been halved down to 2,000 grams? Did I lose anybody yet? After 14 days, it's been halved. At what point will it be down to 1,000 then? Okay? But if I wanted to know when there was 1,500, it's not exactly in between there somewhere because it's decaying exponentially. So we have to come up with a formula that will do this. The initial amount, or original amount, times whatever we're multiplying by, x over how often it's happening. So if we have 4,000, and what is our rate for this problem? What is it doing over and over and over? It's taking half. Okay? X we don't know how many days it's been, well, we do, we're gonna put some numbers in here, but X over how often is it having? Every 14 days, so we're gonna put this over 14. Because if we put in a 28, here, 28 divided by 14 is 2, and it will have twice in 28 days. Does that work? All right, so there's our formula. Now, put in a 28 and put in a 100. And then you have a couple choices for C. We could graph, we could look at the table, which will take a long time, by the way. Or we could preview tomorrow's lesson and talk about how to solve this. We want to know when this gets down to 1 gram. Someone could be working on the table and see what you get. I did it by the table earlier, but it took a long time to scroll down until there was less than 1 gram. Okay. Algebraically, what do you want to do to solve that? You're back in Algebra 1. Divide by 4,000. Alright. This is huge, guys. If I can teach you one thing in this chapter, the whole reason logs were invented is when x is in the exponent, we need a log. When our unknown is up in the exponent, we need a log. So we are going to have to take the log of both sides here. X is in the exponent, we need to take the log of both sides. That's going to be, we're going to do all kinds of equation solving tomorrow, and it's going to be part of it. But it doesn't matter which base, doesn't matter if you use ln or log, but you're going to need to do the log of both sides. Now where can I write that exponent since it's a log now?
In the front.
I can move it out here. Okay? Now, which of those things can you push in your calculator? All of it except for the x, right? So you can solve however you need to find the x. I would have probably divided the log over here. Okay? And then once I get this crazy decimal, I'll still have x over 14. Somebody want to give me that crazy decimal? Log of 1 over 4,000 divided by log of 1/2.
I got 12.0.
What is it, 12.0?
Yeah, that's also after a while.
No. What do you do to get rid of divide by 14?
What?
Multiply by 14 and it should be,
7.5.
what?
167.5.
So which day would it finally go less than 1 gram? And if you scroll down, if you type this original equation right here into your y equals and you scroll down in the table, it goes to like 0.97 at day 168. Did you do it that way, Caleb? I'm good with that. I don't care which way you did it. Because we haven't done this yet, but I'm trying to introduce this idea for tomorrow. All right. What else? Did you have other ones on this one, Carolyn?
I have a question on 17B.
Could you do
Is this 17 or no?
This is,
Oh, this is,
Could you do B on that one?
yeah. Can I talk about this question, Caroline, and then I'll get to yours on worksheet 17, I promise. Does anybody remember how to use the finance menu from last Friday?
Yeah, I do a little bit.
Okay. This one says we're putting away, Ken and Barbie are putting away monthly for baby Bubba to go to college, okay? I actually know people named Ken and Barbie. All right. N is what? How many payments are they gonna make? 12 a year for
Oh, no, I'm on number
18 years.
Sorry.
12 times 18. What is I? Okay, what is present value? What is payment? What is future value? That's what we wanna find, right? And payments per year,
12.
and compoundings per year. Okay, so go to the finance menu and do this, everybody, so you remember where it even is, do you remember how to get there?
Yeah.
Go apps, finance, TVM solver, did I get the letters in the right order this time? Type this all in, then on future value, when you put your cursor there, you go alpha, enter, right?
Yep.
What'd you get?
17,012.
0,
Yeah, 012.9.
92? Okay, so that's Bubba's college fund. Okay, he's in pretty good shape, right?
For like 2 years.
Depends where he goes, if he goes to
Rock
a
Valley.
state school,
He's
or
in good
Rock
shape for
Valley and then
Rock Valley.
somewhere, yeah, alright. B says, Grandma says, I'll give Bubba the money for college, okay? But who knows if Grandma's gonna be around in 18 years? So we want our money now. Okay, whatever, we're gonna put the money in one lump sum, we don't wanna make payments, okay? One lump sum. Any ideas? We can use the finance menu to do this. What is our payment gonna change to? 0. All we're gonna do is change this to 0. And what do we wanna change and find out now? We wanna leave this in our future value, but we wanna find the
Present value?
present value. Very good. Put your cursor on present value and see what you get.
17,143.
Okay. This is what we'd have to put in there today and leave it alone and never touch it for 18 years for it to grow to be worth this. Now, I wasn't positive if we did this right, because you kind of tricked the calculator into telling us, you know, because we're making $0 payments and I always get nervous about that N. So I did this. I said, well, what if that is growing, compounding at 8? What should that equal? The 72,000, right? Okay, so type that in and double check if you get the 72,000. It's the, on my computer, so I hope I'm talking loud enough for it to pick up.
Yeah.
It checks, right? This comes out this number within a penny or so? Yes? Okay. So this is the answer to A, and this is the answer to B. This was just our check down here. Okay, I'm gonna talk about worksheet 17. See if maybe my tablet is working. I have my doubts.
Talk about worksheet 21.
Okay guys, worksheet 17, which question, Caroline?
Number 4.
Okay, you do have to do all of worksheet 17, guys. I know it said at one point we were gonna do the odds in class and the evens together, or odds together and evens were homework or whatever. Because we didn't do that, you need to do all of it. It's all fair game for the homework check. I can do some of the odds if you want today, I don't care, but this question number 4, Caroline,
Do you want us to write as 10 to the, or do you want?
yeah,
us to-
I thought, okay, properties of logs. Well, let's see, if I subtract that other log over, then I'll have 2 logs that are subtracted. I could write it as a division. I could rewrite it as an exponent, but you want to know what the answer key is? Anybody see something really easy we could do?
Add the 1.
We
Bring out-
could,
bring
but
out-
using the properties of logs, the log rules, what could we do?
Bring out Angela Brown.
Yeah, that's the only thing they did. That's their answer. They wrote log of E equals N times the log, well, I shouldn't have written that, the parenthesis there. N times the log of 1 plus R over N minus 1. That's all they did was
Dude,
brought
I
that
just got
in.
right.
Hey, they're
I
just trying to
just
make
guessed
it
and I
easier.
got it right.
I thought, you know, we should move this over here and that it would become a subtract because there's two logs on the same side and then we could rewrite it as an exponent and, yeah, no, that's all they did, so we'll go with it. Carrie? Yep. I think it's just a formula. It says computer hackers are often interested in passwords to gain access to your system. There are about 256 keys someone can use to make a password. All right? It's very important, guys. They're counting all the keys and all the shift stuff, okay? So if you just use letters, that's a whole different ballgame. But if you use all 256 different characters, if they had to guess out of all of those, it would take them this N is the number of guesses, right? Number of combinations to get your password. Okay, so this is the length of your password is L. So if you wanted to make sure they had to do at least 10 to the 15th guesses, where would we put 10 to the 15th? Of 10 to the 15th, okay? Then we would figure out how long our password needed to be. Now, if we do this, if you don't have a calculator that does bases, remember you have to do this, change of base, which I'll do it that way even though mine does bases. 10 to the 15th divided by log of 256. Yeah, just a second, I gotta. Okay, I got 6.23. You can't have a password that's 6.23 letters, but it said if you want them to need at least 10 to the 15 tries, so we need to do what? 7. We need to round up and say 7 characters long.
I seen a thing on Facebook that it was sum of infinity to find out your web key password. To ignore your web key password.
On that calculator, you do math, arrow up, and it says log base. Okay? Amber, math key?
What?
You know how to type this in?
Yeah, I already did
Okay,
that.
you're
That's how I
good.
got my
Okay.
answers. Yeah, I'll just check with you.
Yes, I talked about that yesterday as well, yep. Alpha F2, which is window, yes. See, I can even do it on this one, alpha, and then it says log basis choice 5 here, and then I could put in the 256 and the 10 to the 15th.
I just tried to calculate how many passwords you can make with 7 characters and 256 with a lot.
All right. Did someone else have a question on worksheet 17 or 18? Did someone say another one they wanted me to do or not? What? Which one are we on? It's just like this? This one, they give you a weird formula, okay? It's not really a half-life question, it's using a formula. It's the reverse of a half-life question that I would have written, okay? it says T is the half-life. And down here it says the half-life is this. So we're gonna put in for capital T of 5730. And P, or little t, I'm sorry, little t, no, is the time elapsed to the percentage, oh, and the percentage is P, there we go. So what's the percentage that I wanna put in for P back here? Okay, and I need to figure out T. So it just becomes a, yes?
Correction, can you pick up, please?
1 second. Right, if you have an older calculator, you want to type negative 5730 times the log of 0.2 divided by the log of the little base, which is 2. Okay? It's a long time if I remember right. 13,000 or some 14,000?
It's like 13,000.
Yeah. Because it came with the formula, yeah.
Is that in hours?
It's years, guys.
Oh.
Wait a minute. Look up here. It says for carbon-14 to decay to half of its life, to half or 50% takes 5,730 years. So if you want it to decay further than half, all the way down to 20%, does it make sense that it could take 13,000 years? Okay. Years. For example, radiation has a half-life that's hugely long. It means how long until half of it is gone. So if you have something that's radioactive and it, I don't know how you measure all that stuff. I'm not a science person, but it's deadly, and maybe its half-life is 100 years, and it's only half as deadly. Another 100 years, it's half of that is deadly. But if you do questions in science class with radioactivity, you find out, 100,000 years from now, the stuff that's radioactive, like uranium, is still dangerous. But I think this is actually measuring, there's a certain amount of radiation in everything, isn't there?
Yeah. So there's
No. Well, there is a half-life to, for example, if they find old bones, they date them using like the half-life of what the bone, I don't, they have to figure the carbon left in the bone or something. I don't know. Let me go on YouTube sounding really stupid, thank you, okay? I have managed to say 5 things that probably aren't true, so. Anybody else?
Good thing it's just
Yeah.
not everyone's.
No, it is public, but I really don't care, yeah. It's for Sierra. Hi, Sierra. No, she can't see.
What if she puts it out?
It's under Rhonda Hofbauer though, so. What?
You're becoming national hit.
Yes, I wave. What?
A hit on YouTube, you're gonna blow up, get like 1 million views.
Yeah. Yeah, they'll be like,